function I was working on yesterday. We got it most of the way there. So now I'm going to be looking at finishing it up. This is what we got right now. Take a look at what it looks like from the top. So right now I have no variance or no like jitter basically. So it makes sense that it's all tightly collapsed. So that's what we're going to add in now. Point cloud. Library. I can find it like this. All right. So we're actually really close to being done here. The last thing that we need to do I really don't know why. No. Float 0. No. I don't understand why it needs the z-axis variance here. But that's fine. That's okay. That's fine. We can just apply. I guess that would make it only positive, huh? We're gonna apply the Z jitter here, and then that'll be just fine. And what we can do is create a new vector array. To go between generated points and normalized points during our normalization process before we calculate our min and max bounds. We can apply our jitter function which is this guy right here, and we'll just do same thing that we've done before. Like this. And that will jitter the point. All right. Set T vector. So now we're going to do this into this with this. But we also want to add it to this array. Like this. So that'll allow us to apply our... Wait, no, this is wrong. This is wrong. We need to apply our jitter post-normalize step. All of this logic is the same, but this will always be this. Okay, let's get rid of this. This. Post-normalize pre-rotate. Right here, and we'll have to clamp it. So like this, I think. Well, something clearly went wrong. This is what I would have been adding. So right here, we add it to the width times half min-max Interesting. And then if I just oh. Okay. So we fucked something up in here. Put this here. There we go. Although, why is it such a steep angle? Alright, so now if I turn this up to like 0.2, yep, it is spreading them. Could also do this number that I've done before. I'm trying to bias it towards the middle a little bit. If you ignore the proportion of it here, it actually starts looking pretty good. Now, how can I change that? All right. I can't actually tell too much of a difference in what that's actually doing. There we go. It's pretty nice. Nice little spiral point cloud there. Let's increase the volume of points. Well, I don't know. It's quite a few points already, I guess. But I don't understand why the volume of points is changing the shape. Okay. I know what's going on. It's because we're using a determinate, like a predetermined increment, when our increment should actually be calculated based on the number of points we're adding in the arm. And that would also allow us to do things like bias more points towards the middle or towards the outside. Now you can see why I want this on another thread. I mean, the effect is actually quite nice here, I think. Bearing in mind that these are just placeholder textures for all this stuff. All right, so okay, I've added cloud function. One thing I am noticing is that changes the shape of the spiral. This is probably because we provided a static increment. What if instead we calculated the increment based on the number of points given arm one. One to one. All right, so what we're gonna do then is in here, instead of taking the increment in like this, we're gonna take our this value right now it's doing integer division, which we don't want. If we plug in an explicit float though, should work. And that's good, because I don't really want to have to deal with increment as a function anyway. Would it be 2 pi maybe? No, no, no. All right, come on. There we go. Not sure what's going on there. Is it mirrored? Yeah, it is. There it is at 5,000. There it is at 2,000. It's the same, just less dense. Yeah, that's the trick. And then 10,000. Yep, same spiral. Starting to look sort of galaxy-ish. I'm still not sure what A actually does. I'm really not. There it is at 1. And there it is at 0.5. I do know that at 0 it doesn't show up at all. Let's try 1 for B. This one, on the other hand, does have a very obvious impact. It's like the amount of twist. So the higher the lower the B, the more twist. So like 0.1, probably have a lot of twist. It becomes like unusable at that point. Let's try this. We can apply our jitter pre-normalize. That's going to fix the bounding probably. So when we're first generating our points right here, we can do the same shit that we did here. We just need to multiply it by something. Like that, I think. Okay. New idea. Instead of doing it like that, we can simply construct a multiplier. So we take this, we're gonna add this positive or negative number to 1, and then instead of adding here, Likewise, we can do y times this again. There you go. And now the spread increases as the arms get wider, which kind of makes sense if you think about it. I don't like the fact that I'm losing the like globular mass at the center. I kind of liked that. Let's think about it for a bit. How do we apply a consistent modification to these, despite the fact that our scale pre-normalization can vary like wildly? Okay, I am now Oh, you know what? I don't need a second loop to do this calculation, right? So if I'm adding it here, couldn't this whole block here of calculating the min and max happen as I insert them into the thing? Do this, we do this. All this stuff. Go under outer for loop. Calculate our point. Jitter our point. Calculate the min-max bounds. Alright, so now we're calculating our min-max as we insert our point. Finally, this loop completes. Get rid of this. Get rid of this. This is our inner loop. So after this loop is done, then we can move straight into our normalization step. I think. Let's make sure everything still works. Fucking A. I lost my second arm here. It's not hitting it twice right now. At least it doesn't seem to. The fuck? Ah, that's definitely what it was. Bam, bam, bam. Doop, doop. Now we have 2. Fuck, we don't have 2. Compile, save it. Compile, save it. Bam, bam. There we go. Okay, we're back. Okay, so that takes care of that. And now we're normalizing it. Like, this is great. It eliminates an entire for loop. And all we have to do is some light math here. So what's next? What is next? I think I should clean some of this up, honestly. I still have very little idea what this thing does. When in doubt, just put in a high number and see what happens. Yeah, see, like, as far as I can tell, that didn't do anything. If it does nothing, it will be purged. It doesn't seem to do anything. Except if I set it to 0, in which case it breaks. But at 1, I get this. I'm thinking maybe this would have had an impact pre-normalization, but because we're normalizing it, it's like this is probably dealing with like some length constant or something like that. So, and at 1 on B, .15, we should have a lot of turns. Yeah. Pure spiral. Oh yeah, it doesn't work if I do it like that. Pure spiral. Okay, here's your pure spiral. For some reason it needs some level of Z variance or it just explodes. I still don't understand why. Probably something to do with the particle system. But this is nice in that it will allow us to tune the points. Alright, increment's not an input anymore. A is not an input anymore. B stays, width stays, Z variance stays. But it gets renamed. Alright, let's start cleaning this up so that we can have kind of a good view of everything that's going on. Okay, now we want this value to be controllable from the outside instead. And then B right now maybe be a constant? Oh, we might have just found a better way to control this, actually. It seems like if I set this to like a 0.5, they meet in the middle. Now I wonder if I then increase that. Okay, no. At 1, they meet in the middle then? Yes. Alright, so with that at 1, if I go back in here, increase this to like 6. I'll do that. So with the function I have, as I decrease b, the number of spiral turns goes up. Constructing points diverge. How can I make it so their starting points will be aligned? For the ith arm, calculate the offset as offset equals 2 times pi times I times I This is what I'm looking at right now. This is wrong though. This might be right. The other one was definitely wrong. I could always calculate a center offset. So like every time we enter this loop, right, we're gonna have to build one of these to start. Where's my freaking variables? Yeah. There it is. Okay, so here's what I'm thinking. Default to false. Okay, right here. Something like this. And then now when this is complete, set it to false again. Each arm gets a transform to send its center point to 0, and then we just apply that to every point. There it is. And there it is. Okay, solve it by taking the first iteration of the arm loop, subtracting the first point's location from 0, and then adding that vector to every generated arm. Okay, let's add another arm. I think it's working. Nope. kind of cool, but not really what I'm looking for. Okay, and if I was to, instead of setting this, to just do this, it gets rid of it. So what we have is basically this value becomes arm length. Yeah, I'm not sure that's gonna work. Okay. Okay, I take it back. The arms to overlap arms. So I need to modify the spiral function. Cause the arms to from the origin same as T theta, TB, TA, theta plus theta offset. No, that's what I was doing actually. Basically, the issue arises with more than one arm. They end up with different origins, and the smaller Rotate only the starting point by the necessary angular offset. You do this by applying a simple 2D rotation starting point. Briefly, I want the spiral to function for both arms by terminating. I don't see how decrementing versus a will make a difference. You're still covering the same range of values. The value of R increases as theta increases. This if you like to spiral, you need to set a starting value for 0. Starting value based on the desired starting distance from the origin. For example, if you like this spiral to start when R equals R start, then take the natural log on both sides from which you can determine your start equals natural log of R start minus natural log of A over B. Now use increment 0. The value of R will get closer and closer to 0, making the spiral wind towards the origin. Where's A? Right here. Interesting. So, hold on. Does that mean if I went in here and I went to my pre-normalized set, and that gets added to generated points, and then when this is completed right here, let me just skip the normalization. We're hitting the edges, but whatever. Alright, so now, hold on. I want to try something. This. Don't do this at all. Okay. Doesn't work. 0.1. Are you kidding me? It does nothing. It's just scale. Oh, it's totally fucked because it's going in, being inserted into the occ tree, and we're exceeding the bounds of the node we're in, so it doesn't work. So that's at 1. The thing is, it doesn't look like it's changing the shape. It looks like it's just changing the scale. And if that's the case, yeah, it's definitely the case. Okay, so now everybody's inside the bounds. This might be the way to do it right here. Now, if I understand what's going on. So TA 1. Let's close. So TA 0.5. Okay. my B isn't doing anything. What the fuck? What have I done here? All right, so let's clean this up a bit. We have a punch going here. Yeah, what up? Arm count, points per arm. All right, so we don't have to do this silly calculation here anymore. We just set it directly and set this. So set a random stream, set our arm count, set our points per arm, start setting our constants for the spiral function. Thanks. I really appreciate that. These. Get this. Points per arm is getting deleted. And there we go. Mid shift. What is mid shift right now? Okay, we'll keep it for the moment. Oh yeah, and I got these. I'd rather do these first because these are ugly. There we go. I do not. I mean, I have a job. I just do this for fun, but maybe if enough people were watching, then I might look into monetizing it, but I don't really care about it, really, as far as from a money perspective. I just like fucking around with shit, you know what I'm saying? Let's see. Points per arm. Okay. Let's do this. Points per arm. Let's leave this. Okay, this is our outer loop. This is calculating an offset value for theta. And theta itself is just getting reset to 0. This, all of this stuff. Move all this down here for the moment. Let's focus on the actual generation loop, not the normalizing and rotating layers. So outer loop. Yeah, it's just stuff that I would be doing anyway. And like, I'm not even trying to have like a huge stream or anything. It's just like if I open up the stream, I get to keep a video of it, and occasionally people will drop by and I can chat with people. So it's a little bit less lonely than just sitting in a cave for 8 hours coding stuff or playing video games. And I'm the type of person to talk to myself while I'm doing this shit anyway, so. So now, okay, this outer loop's pretty clean here, I think. And I think all our sets are good. Let's just call this. I want to get this nice and clean because I'm going to change this into C++ and multi-thread all this stuff. All these point cloud functions that I've been writing for the past few days. And so I need like a nice controllable spiral point cloud, which is what I'm working on here. And now I have it sort of working. I want to clean it up so that I can kind of debug it a little bit easier. TB theta, but not theta offset. That's correct. We only calculate the offset in the rotation, not in the radius. see, this is gonna grab, no? This is calculating our TR for a given iteration. This should probably be setting, well, no, it's setting it in the vector already, so that's probably fine. So this is like and this C variance. Did I set that now? I did. So now I don't need these long unreadable lines. Get everything cleaned up and nice and orderly. Oh, that's nice. Yeah, that one I had a lot of fun with. Actually, if you've been watching my YouTube videos instead of my Twitch streams, they're pretty far behind. They're like a month behind basically because I just have a backlog and I'm kind of like I'm lazy as fuck, dude. You don't understand. So like I usually queue up like a bunch of videos. Like I had a bunch I was just sitting on, so I started and I'd upload like 30 days worth ahead of time. And then like every month I'll go in and go through it and actually figure out which ones to push up. But there's going to be, I've made a bunch of advancements on that, and I can give you kind of I've come up with like a master noise kind of, a master noise kind of idea. Like it's a way to combine different types of noise kind of consistently to get consistent results, and it gets pretty good results. I mean, I can show you actually. Other window. Here we go. So I've got it all rigged up into a proceduralization harness now so that I can seed it and generate random ones. But here's the breakdown of the noise recipe basically that I ended up on. So I had kind of an epiphany one night, and I was thinking I went and took a look at some shit on plate tectonics, and I realized that like there's a pattern that is very common. It's not the only pattern that's formed by it, but it's one of the more common ones. And it's like, it looks like this. And it's a subduction zone, so fault subduction zone, right? And then this is like your uplift over here. And I figured out that if you do a billow noise filter on your noise, it will create things that look sort of like fault lines. So you can take that, and that can form your base continent height map. And then if you flip it, it becomes a ridge noise. And then you can run like powers on it and like math modifiers on it to like increase its fall off and such. But the problem that I was having is that they were overlapping, right? So they would just cancel each other out. So what I realized after a while is that if you just slightly modify the UVs of the flipped version, the mountain noise or the ridge noise, but in like a vector direction by like a very small amount, then it will shift your ridges away from your cracks on like one side of the cracks and not the other side. And it's like it's not perfect, but that ends up looking like mountain ridges getting lifted up by plate tectonics. And then you can also like create a smaller network of valleys that you run through the resulting product of all of that to carve out rivers and valleys and such. And here we go. We'll look at it. There's more to it than that, but here we go. So like, god damn it, I'm going too fast. So like here's one, right? And you can kind of see that like on this side of the continent, we have kind of like ridge lines. But then on this side, it's kind of like more gradually moving down. And you get that like consistently on all the different continents. And then the seeded thing that I was talking about. So I have all this hooked up into a proceduralization harness now, and I can just drag this and change the seed and get different planets. But all these videos aren't out yet. They'll probably be coming out over the next like 20, 30 days. But yeah, this is, I mean, it's all like, it's from space only. Like if you get close enough to it, it's not going to look good. But I'm pretty sure you could use the same concept, write like a really fast multi-threaded C++ wrapper around it to generate and do like tessellation and such. And you probably could use it to generate height maps from space. You just have to realize that the noise is fractal and you can keep making more noise as you get lower in detail. But yeah, this is something that, so I felt like this is coming out pretty good, and that's why I moved on to the part that I'm working on now. And the reason that I'm excited about that is because this right here is a procedural octree that I wrote a while ago in C++. It's all multi-threaded and stuff, so it's very fast. This is slow because I'm running a point cloud function that I have probably got a breakpoint on, perhaps? No. There it is. Okay. So this doesn't look like very much. But all these points are just basically voxels that are like procedurally filled in this octree, and this is the spiral point cloud function I'm working on right now. But so you can take, like, this is just right now it's just a particle system, right? But I can keep it a particle system and then do like a nearest neighbor search at different levels of the octree and pull out entities from it. And then I can attach actual game objects to it, and these cores have like randomization data attached to them. Like they get a random color, they get a random size, and they get a random seed and all those kind of things. And you can bound the ranges of how all that stuff randomizes as well. So the idea is that as you would fly close, instead of seeing like this thing right here, you might see a star or like a black hole in the middle of a galaxy or something like that. And then instead of seeing all these points that don't look like much right now because I just have it, I have no variation in it because I'm trying to tune the spiral itself, you would have stars getting attached to them and things like that. And I want to use this kind of framework to generate a solar system next. So like right now I have it's very big. I mean, like right now we're in a cloud in another huge cloud. So if I like, if I go back to this one, right, I'd have to go very fast because we're very big. When I do, I move out of this cluster, right? And then each of these other points can be a cluster just like this one. You just have to load it in when people get certain distances away from them. And it's all just kind of there. So I want to use this to generate like the hook to randomize my star and my planets and put a bunch of like asteroids and shit. And you can like come up with different, to do a different pattern of things in space. It amounts to basically writing a new point cloud function to generate a normalized cloud of points between -1, 1, 1 and +1, 1, 1, right? And then you can put whatever pattern of things you want in here, and it'll follow the point you generate to put in there. So basically, to get all these algorithms right, this is the last one probably, I don't have to, but it's easier for me since I'm not like a native C++ programmer. I don't do it as my day job. So it's easier for me to get all the math right inside the blueprint. And then I have that like side by side, and I can go and I can write the C++ class, and I'll be able to figure it out eventually, you know, after I bash my head on it for a few hours. But right now I'm working on writing a spiral. And I've actually like kind of gone backwards in the past little bit, which is why I am now doing this. So I think we actually want to set this like this. So I want to be attaching those little planets like all randomized to different nodes, and I'll make a little procedural asteroid, which would be easy relative to the planet. In fact, I can already do it within the planet framework. You just change all the noise to Voronoi, and it'll look like it's cratered. Okay, all right, so this is our initial point on the spiral. Let's do it like this. All right, so next, if we've set our master transform, yeah, exactly. You do a rules-based generation, and you just got to realize that it's all like every layer is just a big fractal anyway, right? So like you can do a normalized point cloud or whatever, or you could do it by like, you could do like density function with a texture sample or something. And so like it's all fractal anyway, so you can make a point cloud and inject it any layer of the octree, and like you can even figure out like roughly what scale you'd be injecting at. Like, so if you have an 80 depth octree, that's 2 to the 80th power in size, and that's about the size of the observable universe, right? So if you have an octree that big, then the things you inject, then you can figure out, okay, if an 80 depth octree is a cube big enough to represent the universe, then what's the rough size, like what's the average space between galaxies, right? So you figure that number out, and you figure out what log 2 of that number is, and that'll tell you the layer that thing should go at. And you can do that all the way down till you get to like, 1 meter sized objects. The only problem is that you'll run into floating point precision errors in like actual movement at those scales. So what you do is you can still use all that. But you restrict the user's movement ability to basically they can only go really at like planetary or perhaps in between star scale movement. And anything bigger than that, if you want to warp from like instead of warping within this, let's say we'll allow them to just like pulse boost around inside a stellar cluster, right? But if they want to go to a different stellar cluster or a substantially further away object, you instead of moving the player, you treadmill the entire environment. So you just take the origin of wherever the player's at, rebase the world to 0, 0, 0 at that point when they start warping. Then you basically warp the entire you attach this whole system to like some object that you can move around, right? So everything's parented to that object, and you start it at the origin, and when you finish generating like whatever system you're going to spawn in, you move that object to move the system you spawned in to the origin, right? And then when you want to warp somewhere else, you would, instead of moving the origin around, you just lock the player's movement, you put up a warp screen, but you can still show like the actual environment changing, and you move the whole environment to wherever you were trying to go is now where you're at, and then you can do it that way. You could also, you could allow them to fly as well, but you have to come up with all the math to change your like physics-based flight model into like I'm scrolling the environment procedurally faster, which I think that's how Space Engine does it, for example. What is this attached to? Why are you jittering back and forth mid-shift? I don't know. Okay, that's fair enough. I don't know if I'm gonna use that one yet, but that's kind of the idea. So like you can allow the user to roam around at like star system scale. You could either allow them to warp between stars, which you could make it like a warp you could cancel out of even, but you wouldn't allow them to basically move during it. And if you do it that way, it's really nice because you know what star they're warping to. So you can just go ahead and load in all the planets for that star before they even start moving towards it. That could be like your warp spinning up sequence. And then you just shift the whole dang system of everything over by that amount. Over like a curve. I actually did that in the other project to make sure that it would work. But then I went and wrote the actual Octree C++ like good stuff plugin that's actually fast in this project. So I'm kind of redoing everything basically. I could just transfer it, but it's like I've been doing it for longer now than I had when I built that stuff, so I can probably build it better anyway, Why am I multiplying this by 1? Why am I adding this to 1? Oh, okay. It's because I'm percentage shifting the points. I'll put some... I do want to put the... Where the fuck's the level blueprint? .3. Get some variance back in it. Oh god, what just happened? Oh, there we go. Alright, so here's what we're kind of working with right now. I need to get the spiral shape correct again because it's wrong right now. I don't know what I did, but I broke it somehow. But once I do that, I like this effect of it like getting wider and less dense as it gets away from the center. But I need to... It needs to be... well, for a single player game, it probably just wouldn't. I mean, you could have like the actual entities inside that system, probably not. I mean, you could have like an overarching AI feature that does stuff on like a system level. In a multiplayer game, you would have basically like a server farm that was spinning up AI servers for any systems that were occupied by players. So, you know, I'm not doing that. I'm sure there's ways. I haven't actually even got that much into AI, to be honest. Like, it's been all just figuring out how to do, like, different shit like this. It would... Yes. In my case, the scale is legit. But it's like, that doesn't give you that much utility, honestly. Like, it would be way easier and probably more efficient to fake it, is you can just make a random skybox pretty easily, and you can warp between star systems, and that's pretty fucking big, and you would not have to fake any of the math at that point, because the large world coordinates are actually pretty big. You get like 80 billion units or something like that before it starts to break down. But for something like Stellaris or something like that, it's like you wouldn't have... Your AI for a given system would be separate from the like existence of being inside that system. You basically have a bunch of agents, like that. You know what I'm saying? Like, I don't know how to... You keep that stuff separate from the actual like game objects. Now, I don't know how it does things like having... If you had like 10 billion systems in like a top-down game that's like all about building, like, I'm thinking like Masters of Orion or something like that. And like Masters of Orion didn't have a lot of stars, so they could just brute force it. But if it had like 10 billion stars, you can't have that many AI agents. So what you would probably do is figure out like areas of influence and then like randomization. Yes, correctly. Correct. You would... So you could say, okay, I have these 10 billion star systems. It's obviously I can't calculate the progression of the civilization on each of these star systems on an independent basis. But what I can do is keep track of the ones that the player's already discovered. Okay, that's basket one. And then I have all the ones that the player hasn't discovered exist in like influence zones of different alien races, right? And those influence zones can themselves be like density maps or something like that, some kind of representation of like technological advancement or age or both. And then you could have another harness that when you discover one of those planets randomizes their initial starting state based on those factors, like how old is the planet, how advanced is the civilization, how populated is it, those kind of things. And when you encounter that planet, you could randomize its initial like technology level and civilization level and things like that, and that could become its initial state, and then it could go in the basket of the planets that the players discovered, which would be a much smaller list, and it can start incrementing. And you could also keep track of like the age of the game, things like that, where like, oh, the game's been going this long, all the civilization should be like this advanced. and things like that. And then it's like kind of faking it, you know? Like you don't have to keep track of the advancement of every planet. You just have to be able to randomize it when you encounter it into a believable range. Kind of like, yeah. Alright, so let's fix this spiral. What the hell? Why is my B not working anymore? B, 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 B. TB, TB. B is supposed to be used here. TB times theta. Theta was set here. Am I incrementing theta properly still? Yeah. This is annoying. I'm gonna do it like this. It's the same thing anyway. I wish I didn't have to do it like this. When you do these, when you randomize shit like this, it's like if you don't hit a second execution pin, you'll get the same number out of both if they're doing the same thing. So you have to do like this janky set. No, dude. I wouldn't stream this at all if the entire purpose I do this is to chat with people while I'm working. I don't begrudge it at all. Jitter Z. Alright, so here we go. If it's false, so we check to see if the transform's set. If it's false, we do this. T vector minus this set. Okay, for one thing, it's times this. Alright, that's fine actually. So for one thing, let's get rid of this. And this is slow right now, but I'm also logging stuff, I think, still. Aha, I know what's wrong. I know what I messed up on. It's this right here. I should probably turn down the number of particles while debugging this, so that it doesn't take me 5 seconds each time. There we go. Now we're getting close. It's not exactly centered. And there should probably be some sort of fall off factor. I'll have to come up with some idea for that. So I think I was doing okay. It's getting better slowly. Let's actually go ahead and make space for this guy. We want to do another set here. Set T vector. And we'll just use this as this, do this, split this, into this, there we go. Now we're talking. Then we finally stick it in our generated points and update the min and max values. Now we don't have to loop a second time to do this. Okay. Then I'm just gonna get another one for this. A little bit easier to read. Oh, let me check. Oh, no, dude. It's no big deal. Let's see. So this last part is pretty solid. It's just normalizing the array and then rotating it. The key lies in here somewhere. And honestly, I'm kind of mad that ChatGPT led me down the route on a logarithmic spiral instead of an Archimedean spiral. Because I didn't know what I was doing at that point in time, but now I kind of do. Sort of. Okay, so this all looks pretty much right. So we'll just do this. Instead of doing B and A and having A plug into the equation A, I'm just going to have an A for now is just going to be a multiplier by pi. Oh, and I was dividing the points, but I'm not anymore, so that's why it's taking so much longer now. And then if I did... Because now instead of doing 5,000 points divided by 3 arms, I'm doing 5,000 points in each arm. So we definitely want to tone this down a smidge. Let's try 1,000. There we go. That's kind of cool. The problem with this is that it's like pulling them out of alignment, basically. I mean, that's kind of cool. It shouldn't be doing that, but it looks kind of, it's like a wave. It's like a little like surf emblem. Yeah, it just will take a while to come out because, like I said, I do them in batches of like a month's worth at a time, and I just schedule them all out, and then I ignore it for like a month, and then I come back to it and do them all again. Sometimes I'll like comment on stuff, but like I'm not very engaged with it. Like I said, I'm not really trying to make money with it. I just want a place to keep the videos. If I ever want to actually like edit them together and make something out of them, then I would have them there and I could do stuff, like if I ever want to pick up learning like video editing, for instance, I would have a bunch of material to work with if I have a YouTube with a bunch of videos. But yeah, I upload them usually once a month. I'll schedule a bunch to come out the next month. I don't know how I did this. And I kind of like, I like the effect. So I'm kind of like bummed to like fix it. But it's definitely wrong. Yeah, so, oh, here, I'll show you. If you want to just start, you can, so you'll want to figure, like, you want to look up a way to basically do a Niagara system from a point cloud, because you want to be able to visualize it. You want to, like, I wouldn't, yeah, I wouldn't, I wouldn't start with the spiral point cloud function because this one is a fucking headache. But there's way easier ones. Like it's literally like this one is just brain dead easy, right? That's all it is. So if you want to make a spherical point cloud that's more concentrated in the middle than it is on the edges, random float and range of stream to the scale that's passed in, right? Um, this is what's gonna like basically make the outside bounds smaller. A random stream with a random unit vector from stream. So random float between 0 and your scale, random unit vector from the stream. Multiply them, add them to your points, output your points. And this is what I'm using for all the other ones. So like if you look, this system is the only one that's a spiral right now. All the other ones are the one that I just talked about. But I have to go really fucking fast to even be able to see it. There we go. And that'll give you one that looks like that. And that's so easy. Like it's you know, it's nothing. It's literally just a random float times a random unit vector. And then you just loop some number of times. Let's find the one that's actually populated here and go back to it. It gets more difficult when you're going extremely fast. Oh, it's so super duper easy. It's actually one of the best parts. Although it could use a 64-bit variant, but this right here and this right here, there's an object called a random stream, right? So make random stream anywhere, right? It has a seed. You pass this in. This outputs a stream. Same type as this, same type as this. It's in a random stream. I'm not going to make one because I don't want to add a variable in this class that I'm not going to use. But basically, this will give you a random stream. You can put a seed in here to start it off. Then what you do is you just pass, whenever you want to make a random thing, random float, random unit vector, whatever, just type in random, you'll see. Every version of this has a from stream option. And that's what you want to use. Because that means that as long as you start with the same seed, everything is going to random the same way every single time. And everything that you randomize in your entire game at that point should pass around these streams. They don't have to necessarily pass around the same stream, but they need to all pass around a stream that's initialized to the same thing for the things that it's controlling, right? And I would suggest just basically always passing around the same randomization stream. Well, what it does is it makes it so that it will always randomize the same. It's the same idea as in the other level that we were looking at with the planet, me being able to change that seed and have the entire planet structure change. That's because there's a bunch of logic in there that's setting values on that material based on values that are being randomized between certain ranges. There's actually a big part of doing that was actually creating the structs that represent that stuff. So, like, for example, here's planet height map controls. This contains, it's just a struct that contains default values for that material, right? But this isn't really the thing that's important. What's actually important is if we go to bounding structs, I have planet height map control bounds, and it has all the same fields, but instead of having one value, it has a min and max value, right? Or it has like different, like a basket of textures or things like that. So when you go to set up a planet type, you're basically finding, say, oh, I want to make an Earth-like planet. So you go, you make the textures to represent the height map and stuff, and then you make one of these structs at the planet level that contains all these substructs, and you go set all their detailed values and you fuck around with them until the planet looks good, right? And you randomize it in a bunch of ranges and you look at them and it's like, okay, this is a good range. And once you've done that, you have a planet type. And that planet type can go in another struct here that has a basket of the planet type structs, and the planet type struct has a selection weight, and this basically can control how often that thing will get picked relative to the other things, right? Right now, there's only one type in here, Terran, which is why when I was randomizing that planet, I was only getting like blue water, greener browns, always had an atmosphere, things like that. But if I wanted to change that and make like an airless planet, I would just have to add a new entry in here, change the color maps and stuff, change the noise, perhaps the weight, the selection weight of the noise and things like that. Like with airless stuff, you want to use a lot of Voronoi because that'll make it look like craters. And then when I go to randomize a planet, again, from that seed, it's picking between these things based on their selection biases. And it'll pick one, and then it'll randomize that one thing. So, like, right now, it's only generating one type of planet. But if I wanted lava that's always, like, a lava planet that's always going to have oceans that glow instead of just, like, reflect light and are not reflective, then you could control that for that specific, like, lava planet type, and you would make an entry in here, lava planet, and you'd say, I want you to have a selection bias of like 0.05, and that means if everybody's selection bias were to add up to 1, then that would mean you get selected 5% of the time. But it's not that strict. It's just a roulette select, so it's your chance of getting selected is whatever your selection bias is over the total selection, like the total of all the selection bias. But that lets you have like certain types of planets that are more common and certain types that are rarer. I've completely swapped over to textures. The real-time noise calculation. So there's a place for the real-time noise calculation, and you could make it work, but it requires a little bit more work. So if you really, this might actually be the best way to actually do it, and be able to like get down on the surface. But if you were going to use that stuff, you would be like using it to bake the material, right? So you could create an object that's like not visible on your screen, but you have like a capture system set up on. You could capture like a super high res like cube map of that material and get it mapped and figure out how to bake it. And then once you bake all that to disk, right, during your load sequence, And then you could go use geometry nodes and like really legit displacement options with your height map, subdivision nodes to possibly do like tessellation and things like that. You might be able to do that. I don't know, but it's definitely too slow to use real time if you're going to use more than like 4 noises, I think. Or it's not like you'll start having problems around 5 or 6 noises is what it seemed like to me, and it's definitely very like computationally expensive. So yeah, for what I'm using right now, or I bought like I don't know, it was like a year ago. I bought like a pack of volume noise for like $5 on the marketplace, and they were just good old fashioned 256 by 256 by 256 volume noise textures, and I've been using those. So using noise makes it a lot harder though, because like you can't switch between noises as easily in a material as you can between textures. So you would end up needing like multiple different materials for each combination of noise and then randomly pick between those. So that's one problem. But yeah, like I think using the geometry nodes you could do some cool shit. I just haven't figured it out yet. I do want to eventually be able to like figure out tessellation, mesh generation, and things like that. But I have enough on my plate just trying to figure this out. So how do I... Thinking. I have to figure out a good range of values for this that look decent. B25. Okay. Is it because I have an odd number of arms? No. My increment's fucked up. Yeah, so I'm using... That was a whole nother rabbit hole that I went down in the past month. I'm not using lit materials for the planets at all. I'm using unlit materials with fake normals. Because it's a pain in the ass to light like a solar system scene that actually has the star in the scene. So if I set everything to unlit, then I can set a primary light source location in like another function, and I can set its color, and that color could be like more than one star color. If you wanted to do multiple different colored stars, you could combine their colors and lerp and all that shit. And doing that, yeah, the one-way directional light's a pain in the ass. But if you do it that way, I wrote like a fake Phong shader and a fake Phong shader, fake like shadow fall off, and the whole thing is luminous, and you just provide an albedo for everything basically. And then the normal map is, I believe, just subtracted from the luminosity or something like that. I forget. It might be multiplied. No, I don't remember exactly. It was like a function I wrote. It was like, take a look. I'm trying to remember now. No, it's in here. Phong apply fake normals. This function here. Yeah, and like they'll all just refer the same function to get their light source direction, and you can make the like you can make the color contribute and everything because you're using like the fake Phong shader with all this stuff as well. Yes. So like this function takes in a light direction, a normal map, and a light color, and an original color, which is like the color of the thing that it's so like whatever your output for what it's supposed to look like without normals comes in here. Your actual normals come in here. Your light direction is set to whatever you want it to be, and your light color is set to whatever you want it to be. And then the output result of this will be the same thing you put in, but with the effect of having like a normal map, but in an unlit material. So like, we go back here. I'm too fast again, fuck. Alright, so this is unlit, but you can still kind of see the effect of the normals. You see what I'm saying? We're also on the dark side, I guess? No, it's just fading in. But yeah, this is all fake. All the lighting is fake here. This is just an unlit material. Same for the rings, because it's really hard to get the shadow on translucent stuff right. And just like, basically we have a few functions, like I have this Phong function and this apply fake normals function, and in the master material the last thing it does before it composes it into the layer is apply Phong to the color output with all the things set, apply the fake normals after the Phong, and then you don't gotta worry about this, but this is basically like increasing its luminosity as you get further away from it, because otherwise you just lose it super fast. But if you do this function, it will cause it to like glow and kind of glimmer as you get further away. So like, I'll show you. Like, it would be invisible by now if it wasn't getting like its luminosity boosted, basically. And definitely by now. I do the same thing on the atmosphere. All of it? The only two things okay, so all I do is pretty much all of it. I do the color output, the height map color output. That's a temperature on the y-axis, height on the x-axis sample of a gradient. And then the output of that gradient goes into the Phong, along with the information about where your light is. And the light could even come from like a material interface where you just set it for everybody in the stage, right? And then the normals plug into the output of the Phong, and you get this. I mean, there's a little bit more to it than that. There's still like, you have to control the specularity, and it works differently than the specularity that you're used to. So like you can't, it's not 1-to-1 with the unlit or with the actual lit version. I mean, the lit version looks okay too. Don't get me wrong, but this is the one that I've done the most work on. So like for this, I just had ChatGPT and the internet basically help me write these, but like this was how it described to make a Phong shader on the internet, and I just did it. And then this, I forget where I saw this, but I saw somewhere had somebody talking about this. And this is the rivers I was talking about. Like, they're not perfect. Like, you get loops sometimes. But, like, if you're not looking super close at it, it's harder to notice. Oh well, I'm actually no. I'm a little bit. I lied a little bit because I'm also applying. Where is it? Somewhere I'm applying like a shadow shader. I forget, but it's the thing that's doing the light and shadow variation here. I need to make more of these planet types because I'm about to be able to start plopping them in the stage at random. The other cool thing about doing the mountains the way I was talking about is that when you have mountains that get closer to your shorelines get like more tumultuous, which is cool. And you get these little like archipelagios or whatever of like mountain ridges that are poking up through the ocean, and it just like sure. Yeah, it's actually, I mean, it's pretty trivial. You just I mean, you already get that information in the material at least by your world position after the world position offset, right? But you also get, you can sample, like the output of the height map function is just a grayscale, or it's actually a packed, it's three grayscales packed together, but you could sample any of those at a point. Yeah, I think so. You do like a line intersect. If you could sample, as long as you can sample the material, you'd be able to just sample the height map at that specific world position, and whatever its value returns, you could multiply by a multiplier, right? And then figure it out. I'm not. I mean, it's probably more complicated than that, but I like this. This looks good. Where it gets like mountainous and all choppy on the shorelines versus like the smooth. Kind of seeing more of the like earth-like features cropping up here, where you get like the ridges on one side where you probably got a fault over here, and then another one like over here. All right. No. Gotta go back to the grind though. I need to make a bunch of planet types, so probably this weekend I'll probably just sit around one day making them, because it's actually kind of fun to make the randomization bounds. You just fuck with the numbers and it changes drastically. I need some dinner here pretty soon too. Here on the blueprints. There may be better ways to do it than this. The only way I know currently is you could bake it. So you can bake it to you could bake whatever relevant information you need into an actual texture that you're holding in memory. And then you can sample that. There's probably other ways. I mean, you honestly, you could probably do it. I don't know how good the collision is on that displaced terrain, to be completely honest, but you might be able to do it that way too. Just like a line collision. But I'm not actually sure about that question. I would have to sit down and face smash on it for a while. Get root. I know you could bake it. That's just not like a super appealing thing to have to do, because that means you have to set up like some folder with a bunch of blank textures in it, and then you have to like you gotta always remember which one you're working with, because it's going to be difficult to do it procedurally not using C++. Now, using C++, you can do whatever the fuck you want. So you can just have it write them out to a file folder, and then have like write the baked materials out to a file folder, and then have your sample material, whatever, pick it up from that folder. But just in blueprints, you would have to bake it to like static textures, probably, to sample it in a blueprint. I'm fucking confused. Okay, so let's see. Aha. Why? The fuck? Yeah, because you would have the center of the planet and you would have the radius of the planet baseline, and as long as you're only modifying the height in the world, in like the what is it, the vector normal world space or whatever, that you have to multiply for the, when you do the height offset, you have to multiply your grayscale by, it's like vertex normal, I think, or something like that. And then you could at least get the vertex, maybe pixel normal world space or something like that. I don't actually, I haven't done a lot of the interactive stuff, to be honest. It's been building stuff. Yeah, I've done some collision box stuff. I got a little spaceship I can fly around that's not super great, but it's like physics based at least. And that's it. Everything else has been making textures, making octree, making materials rather than textures. Although I did make quite a few textures. This is good, but it gets completely fucked. Oh, I know what's going on. I know at least something that's going on. Arm count minus 1. But I know that you can do stuff with textures rather than materials. And I know that you can bake a material to a texture. And I know that you can bake that texture with a cube map, but not at a very high resolution. And I suspect, basically know that you could also rig up a bunch of cameras to capture that cube map at a much higher resolution, and then do like an HDRI with it. And then you can get some really fucking high res shit in your height map, and then that would probably be good enough to do like landscapes and stuff that you could walk on. Or get closer than what I have anyway. So I need to get some dinner, because it's late. So later.